All right, this is Pre-Algebra lesson 9.3, classifying polygons. Let's talk about this. You've done this before. I know you have. I know you did it last year for sure. I'll wait till you guys are ready. Classifying polygons. Today's lesson has very little to do with math. It has a lot to do with you just memorizing these terms. Okay. A polygon, P-O-L-Y-G-O-N. A polygon is a closed figure with at least three sides. A closed figure. That you see it without even realizing it. But here's the deal: is that a polygon?
Yes.
Yes. It's closed, right? It's an actual figure. It is something that has no openings. Polygon. Is it a polygon?
Yes.
Yes, it's closed. Polygon.
No.
No, see, it's not a closed figure. It's not a figure at all. It's just a bunch of lines, right? A bunch of line segments, right? But if all of a sudden I went like that, polygon. Make sense? Polygon. What about this? Is this a polygon?
No.
No, why not?
Because it doesn't have three.
Doesn't have lines, right? Those aren't segments, right? This is a curve of some sort, right? That is not a polygon. It has to have straight line edges. It has to have straight segments on the side. So, I can make a polygon that looks like, still a polygon. You know what I'm saying? Still a polygon. And yet, if I was to change one thing about, not a polygon. Make sense?
Yeah.
Not a polygon. Okay. The simplest of the polygons is triangles. There are two ways to classify triangles. You classify triangles by its sides and by its angles. Okay? You classify triangles by its sides and angles. Here's what I mean. If I gave you that triangle right there, and I asked you to classify that as in like, if I was to ask you to look at that and go, okay, what type of triangle is that? There's three different types of triangles when you're talking about the sides. If two of the sides are the same and one of them is different, that's called an isosceles triangle. Can you tell if that's an isosceles triangle? No. One, I'm a human being who's just drawing, and maybe I meant to have that side and that side be the same, but you're never going to know for sure because I'm just drawing with my finger. Does that make sense? So then, how would I tell you that I meant for this side and this side to be the same length? What could I do, Brad?
There's the lines of
The little hash marks, right? If I go like this, if I was to give you that right there, and they're the same thing. This one has one hash mark. That one has one hash mark. That hash mark is telling you that this side and this side are the same. Does that make sense? And then I could either leave it blank down here, or I could go like that. And now, because there's two hash marks down here, it's very clearly telling you that that is one length and that is a different length. If I wanted this length to be the same as this length, what would I do? What would I have done different?
Put two marks on the bottom thing and two marks over there.
Right. As long as they're all the same, right? Then this tells you that I meant to draw all three the same. Does that make sense? And so you trust them. You trust those hash marks more than you trust your eyes, because if I'm just drawing, first of all, is that the exact same length? Is that? Not really. But because I put those hash marks, it's telling you that I meant to do that. That's what was supposed to be there. Okay. So, based on this, if I give you this triangle here, now listen, there's a couple of them. I could go like this. And go bang, bang, like that. That is an isosceles triangle because two of the sides are the same. Right? I'm telling you it's isosceles, right? Look up there to isosceles. It's in the bottom middle one, right? I could do that. I could have these like this. And that one be one, or I could have this one be three, and this one be two, whatever. As long as it's showing you that those two are the same, that one's different. That's an isosceles triangle. But what about this? Could this be an isosceles triangle, tall and skinny?
Yeah.
Yeah. That's also isosceles, right? Two sides are the same. Do they have to be up, right side up like that? Could it be like this?
Yeah.
Right? Could be. I mean, don't get all hung up on, ooh, it's upside down, right side up. Okay, if all three sides are the same length, what would I do to indicate that? What would I do?
We have the same one.
Right, three are the same. I could either do, I would always do one because it's the easiest. Why do two when I don't have to? But that's an equilateral triangle. Equilateral meaning that all the sides are the same. Make sense? Okay? And then the other kind is if you have something like this, and I'm trying to show you that they're all different, I would go 1, 2, 1, 2, 3 like that. When all the sides are different, then this is called a scalene. You're going to have to memorize that. You see the bottom 3 down there on page 470? You just have to memorize those. I would like to think I know you had to memorize them a little bit last year. I know you did. And so, but you just have to memorize them. That's how you classify them, having to do with their sides. Yes, ma'am.
Wouldn't it also be?
Maybe. Here's the deal. If I just gave you this right here, you could not tell me that was a right triangle. Why not? What if I meant for that angle there to be 91 degrees? You and I, with our eye, wouldn't be able to tell what I meant. Does that make sense? So let's talk about this, though. Let's just say that I do have a triangle like this. Now that we're talking about the angles, here's the deal. Okay? If there is a right angle in a triangle, first of all, how many right angles is it possible to have in a triangle?
One.
Is there any way to have two?
No.
Not possible. You couldn't possibly have two right angles in a triangle because it wouldn't be a triangle anymore. I'll explain here in a second. Obviously that's the angle that you would think maybe I was trying to make it be a right triangle. Does that make sense? A right angle? How could I let you know that I was truly intending on making that a right angle, Jack? What could I do?
You could put the box.
The little box, right? If I go like that, that's telling you that I meant to put that at 90. If I don't have that thing, and you tell me that's a right triangle, I'm marking you wrong because you don't know. I mean, what if this was, what if this was 89 degrees? What if that angle was 89? You wouldn't be able to tell with your eye, right? Or if this was a 91 degree angle, you wouldn't know. Oh, but as soon as I put the box, you know what I meant to put, and it's a right 90 degrees, right? Okay, so then this right here, this triangle here is a right triangle. Why? Because it has a right angle in it, right? So you look at this and you go, okay, there's this, this, and this. If I was to ask you to identify this triangle, you'd have to give me two things. What would you say this was? A right scalene triangle. This, you base it on its sides and you base it on its angles. Based on its sides, it's scalene, right? Right?
Yeah.
Based on its sides, it's scalene, and based on its angles, it's a right triangle. Therefore, it would be a scalene right triangle, or a right scalene triangle. I don't care what order you put them in. What about this? Now, here's the deal. You can just look at this one if I gave you that and like that. First of all, based on, well, you could actually give me all of them here. What is this? This is an isosceles, right? Notice this. There's another rule about the angles. If all of the angles are acute, what's acute mean? What does acute mean? Smaller than 90. Smaller than a right angle, right? If they're all skinnier than that, right? Skinnier than a right angle. If all three are skinnier than a right angle, then that makes it a acute triangle. Does that make sense? Based on its angles, it would be acute. So forget the hash marks. If you saw this right here, that one's kind of close actually. You can tell that is less than 90. Agreed? That one is less than 90, and that one's less than 90. Since they're all less than 90, it's an acute triangle. Does that make sense? Now, so the one up here, since we can see that they're all acute angles, it's an acute triangle. It's also isosceles, so you'd say this is an acute isosceles triangle. Make sense? Okay. And then the last one would be, right? What if I gave you this? See, that one could easily have been isosceles, right? But what if I go like that? You go, oh, you didn't mean to do that. So, an obtuse angle. What's an obtuse angle?
Bigger than 90.
Bigger than 90. Is there any obtuse angle in that triangle?
Yes.
Yeah, this guy right here, clearly bigger than 90. Therefore, this is an obtuse scalene triangle, right? Obtuse because there's one big angle. Now, why is it that you can never have two obtuse angles in a triangle?
Because that it wouldn't be a triangle.
I'm going to show you the math, okay? Anytime you have, well, let me get a, I'll make a, what is it called when all three sides are the same? Equilateral, right? Not acute, equilateral. If all these angles are equal, I'll tell you right now that all equilateral triangles, their angles are 60. What do you notice that they add up to? What is 60 plus 60 plus 60? 180. Did you know that if I did this right here, and this is a right angle, you know, and so then this would be 90, and this one would be, we'll say 30, and this one is 60. Did you know what is true about all triangles?
They all add up to 180.
The internal angles of any triangle adds up to 180. That's the truth. The internal angles of any triangle adds up to 180. Okay? So then, think about this. If that is a fact, that the internal angles, I don't care what it is, that makes this be like, 140. This could be 25, and this could be 15. The point is that they're always going to add up to 180. Okay? So then, let's try and do this. Let's say I have one obtuse angle here. That means that what is this angle going to be?
Larger than 90.
Bigger than 90, right? That means this is going to be bigger than 90 degrees. No matter what I do, if I tried to make one that was bigger than 90, you see how that would be bigger than 90? Okay, that doesn't work. Or this one would have to be bigger than 90. Wait, oh no. It has to come across here, right? If one angle is bigger than 90, then the other ones have to be what?
Smaller than 90.
Smaller than 90. They have to be. There's no way. Otherwise, to make another one that's bigger than, it's not a triangle anymore. Does that make sense? Mm-hmm. Just like you cannot have two more, if I did this and had a right angle here, okay, is there any way I could have another right angle?
No.
Because then again, look, because this is 90 plus 90, I don't have any more room. There's no way to have another, you can't have two 90s, because 90 plus 90 is 80, is 180, and that gives you no more room to have your third angle. Does that make sense? Okay. I'll give you another little clue here. Did you know that I don't care what the quadrilateral is? That, the angles, internal angles add up to, in here? Not 180. It's not a triangle anymore. No. Well, we could do this. Let's look. Well, here's the deal. Let's just say this. Let's see. Let's do a crazy one. Let's since that we know it's going to all be the same. What is you agree that a square is the simplest of the ones? So then what is that? 90 times 4 is 360. So you're right. All quadrilaterals, their internal angles are going to be 360. Right? And there's also a rule for if you have any pentagon. We're going to talk about that here in a minute. Anyway, okay, so that's how you do triangles. You base it on its sides and on its angles. An equilateral triangle, this is the one that's kind of weird, is if it's an equilateral triangle, you don't need to say an acute equilateral triangle. Is there any way that you could have an equilateral triangle and have it not be an acute triangle?
No.
No, it has to be, this has to be 60, this has to be 60, and this has to be 60. So equilateral triangles are always acute. So if they say to, tell me this triangle, all you need to say is equilateral. That's it. You don't need to tell me it's an acute one. It's obvious. Okay? All right, now we're going to talk about four-sided polygons. And that is this. You could have any four-sided figure is called a quadrilateral. Quadrilateral. A quadrilateral, what's quad mean? Four sides, right? That is the most basic one. So when you're going down through this, you have to kind of like you're filtering through here, right? You have this shape and you're going to put it in the top and you're going to see where it lands. The first thing you go, okay, it's a four-sided figure. So it's for sure not a square, a four-sided figure. I put it up here. I put this guy up here. I take this guy right here. Now, I take this guy right here. Listen to me. I take this guy right here and I throw him in the top. It's for sure a quadrilateral, right? It's four sides. Okay. The next little sifter, it goes through is there's something else it could be. I take my shape again, and it could be if I have a figure that does this, where you have not even a right angle. If this line here and this line here, if there is one set of parallel lines, that makes it a trapezoid. Does that make sense? One set of parallel lines. If it only has one, so it could look like this. Do you see this set of parallel lines there? That could be a set of parallel lines. Is this and this parallel? No. So then how many sets of parallel lines are here? One set. If there's one set, then it is a trapezoid. Right? So would you look at this and say that that's a trapezoid? How would I show somebody that I meant, because if you look at my shape here, could you be sure that I meant to make that a trapezoid?
No.
You can't, by looking at it, no. How could I then make it clear that I meant to draw a trapezoid? What could I do?
Oh, you could put two right angles.
No.
You put the little lines.
I can't do this. That's not how it works. Here, I'll show you. What you do is you draw a little arrow. See, when you do it like that, that is letting you know, and it could be two arrows or one arrow, whatever. That's letting you know that those lines are parallel. Does that make sense? It's letting you know those lines are parallel, and so go, oh, there it is. Now we know this is a trapezoid. Good, you got it. I bet. Okay, what about this? What if there is two sets of parallel lines? Whoa. First of all, that looks like it could be two sets of parallel lines, right? How would I tell you that they were arrows, right? So I could go like this, and then here would I go one like this, just one? No, I would go two. And that's telling you that that and that is parallel, and that and that is parallel. Does that make sense?
Yep.
And so then now that if there are two sets of parallel lines, that is called a parallelogram, right? That's a parallelogram. So remember, you drop your whatever shape it is in the top. First thing you look for is what how many sides is it, right? So in my shape here is a four-sided figure. So drop it in. Ooh, it's a quadrilateral. Awesome. Then you look and go, is it a trapezoid? I don't know. Let's see. I have a question. Is that thing at least a trapezoid? Does it have at least one set? Yeah, right? But it's even more specific than that. This one has two sets of parallel lines. Therefore, it is a parallelogram. Does that make sense? We're starting to get more specific. Now, there is some other special types of parallelograms, and that is, what would you call this? Now, first of all, if you look at that, what shape might you call that? You might call it a rectangle. How would you know that I meant for it to be a rectangle?
If you did the boxes.
I would need to put this here, right? A rectangle has four 90-degree angles. Does that make sense? Four right angles. Now, listen, if you saw me and I did this, I would say if I just have this one little box here, then I'm letting people know that this is supposed to be four 90-degree angles. But whatever, I'll put them all in here. That's telling us that this, if they're all 90 degrees, what is for sure true about these two? They're parallel. What about these two? Parallel. So this is a parallelogram, right? That is a parallelogram, but it's a special kind of parallelogram called a rectangle, right? That's a rectangle. A rectangle is a parallelogram. So listen, this rectangle is lots of things. Look, that rectangle is a parallelogram. It is a quadrilateral, right? And it is a polygon. Right? You first start out, it's not really a trapezoid. Trapezoid, by definition, only has one set of parallel lines. Okay? What's another special type of rectangle then? Yeah. What if you have all of these here, they're all 90s, and they all are the same length. Do you agree that that is still a rectangle? It is still a rectangle. It's just a very special kind of rectangle called a square, right? That's a square, right? There's another thing you got to be careful of, and that is this. What if I did this? What makes this a square?
4 right angles.
Equal sides
90
and
degrees.
4
4 equal sides and 4 right angles. What about this? Because look at this. What if I have this right here, and I have them all be the same length? Oh, you look at that and go, wait a second, they're all the same length. Is that a square?
No.
No, that's called a rhombus. If all the sides are the same, it's a rhombus. What makes it a square is that they're 90 degrees. Does that make sense? So listen, there's not a whole lot else I can teach you here about this stuff. Consult these charts, right? Consult the charts. Because if I gave you this shape right here, if I gave you this shape, and I told you that there was this, and I said, name for me all the things that that is. I want you to classify this with everything that it is. What would you say? It's a rhombus. What else? It's a parallelogram. What else?
Quadrilateral.
It's a quadrilateral.
Parallel.
It's a parallelogram. What else? It's not a trapezoid. You would also call it a polygon, right? That's the most basic one, right? My point is that you have lots of choices. Just like if I gave you this. First of all, if I gave you that, what would you call that?
Square.
Wrong.
No, you call that
That's a rectangle. How do you know it might be a square, but I didn't show you that. How would I show you it was a square?
with
All right, each line has to be the same. I didn't, so you got to be careful, right? Might look like a square. This is a rectangle, right? And it's also, is it a rhombus?
No.
Yeah.
No.
Yes,
Rhombus has all same sides.
No.
Does this thing have all the same sides? Maybe. I don't show that, therefore it's not right. So you've got to be careful here when you do this. Got to be careful when you do it. Okay, here we go. One last thing. An equilateral triangle is called a regular triangle. Ooh, regular. Regular means regular. It means that all the sides are the same. So what would a four-sided, all the sides and the angles are the same.
Equilateral.
This is an equilateral triangle, but you would call this a regular triangle because all the sides are the same and all the angles are the same. Okay? So then what would a four-sided regular polygon be? A square, right? That would be, remember, all the sides are the same. They all have the same angle. This is called a regular quadrilateral. Does that make sense? Okay. I'm not drawing this very well. But what does that look like? Stop sign. A real stop sign, that all the angles are the same, right? And all the distances, all the sides are the same. Therefore, what would you call this? A regular octagon, right? A stop sign has 8 sides. This would be a regular octagon, right? And then, you have the ones that are the 6-sided ones. Again, I'm not very good at drawing these. If I did this would be a regular hexagon. Does that make sense? Same sides, same angles, regular.
You would know though that the same angle are the same.
You would. You just would. You could tell. Yeah. Okay. Okay, let me see what I have you guys do.
Wait, on number 1, would you call that a regular triangle? Can tell me.
You can't. I would say that number 1, what would you call that? I mean,
Cute.
you'd call it,
Cute equilateral.
remember, equilateral it's implied that it's acute, right? And is there any way, it says judging by appearance. So when they say judging by appearance, you can do your best, right? I mean, like they're saying that they're not specific. Number 1 looks to me like a
Equilateral.
equilateral triangle. I would say that's fine. Number 2, judging by its appearance,
Right angle.
a right
Triangle.
could be, I don't know. Don't you think that the top and the bottom of the sides look the same?
Isosceles.
Number
So it'd be
Number
isosceles, right? 3, you kind of look around and go, I don't know, right? So just do your best. I'm not going to go, you guys do your best, right? I'm not going to go over each one of these with you. Okay, today's Friday, man. Yeah. Your homework. I have page 473. I'm going to have you do 1 through 23. All don't do 10 through 12. Okay?